Hi everyone, it is Devi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about low pass sampling, aliasing, and how to reconstruct the sampled signal. After completion of this study, the learners can understand why sampling is needed. They can gain knowledge about sampling, also understand the concept of sampling. First, we will go through the need for sampling. Analog signals are converted to digital signals through a process called sampling. This is important because sampling reduces the highest frequency which is present in the analog signal. So any signal which is greater than half the sampling rate will be folded into a lower frequency that is less than half the sampling rate. So to explain this concept, let us consider block diagram of any analog to digital communication system. Let the analog signal is given as the first block which is present here. So first block is the analog signal. So this analog signal is given as next block which is called as PCM encoder, otherwise it is called as formatter. This formatter block consists of three separate blocks which are named as sampler, quantizer and encoder, performing the functions called sampling, quantization or quantizing and encoding. After encoding, this analog signal is converted to digital data so that the highest frequency which is present in the analog signal is reduced after sampling. So that sampling is necessary for any type of communication. So analog to digital communication consists three important processes as we said: sampling, quantization and encoding. Formatting an analog signal proceeds three steps as we said. Sampling, it is known as discretization or discretizing the signals in time, which is known as sampling. Next is discretization or discretizing the signal which is in amplitude. So after quantization, the signal is converted to discrete in time and also discrete in amplitude. The final step is encoding. So the quantized values are simply encoded. So the encoded values will be binary zeros and ones. So after sampling, the continuous time signal will be converted to discrete time signal which is represented as different discrete time intervals Ts. So after quantization, the converted discrete time continuous valued signal will be converted to discrete amplitude signal. So analog to digital conversion simply includes sampling, quantization and encoding, and in this video lecture we are go through in detail about sampling. It is a process of converting continuous time analog signal which is named as XA of t by taking the samples at different time intervals. Sampling analog signals makes them discrete in time. After sampling, the amplitude is still in continuous form. So if it is in continuous form, again the process cannot be done, so that the continuous amplitude should also be converted to discrete time amplitude by the process which is called as quantization. So for properly doing the sampling, one Nyquist theorem should be satisfied. Let us see about the process of sampling. Let us consider the analog signal or continuous time signal at different discrete intervals. Let the discrete different intervals from x of 0, x of 1, x of 2, 3 etc. in positive direction, and in negative direction -1, x of -2 and x of -3. So we are going to find the sampled value at different discrete time intervals. So the sampled values the value of the function at the different sampling points. That is, let the sampling point x of 1, what is the value of the function, and what is the value of the function at x of 2, that is called as sampled values. And sampling interval, the time that separates sampling points, the TS, that is called a sampling interval. So the optimum sampling rate depends on the maximum frequency component present in the signal, that is called a sampling rate. So it is otherwise defined as sampling frequency Fs. S for sampling, F for frequency. Fs stands for sampling frequency. Fs is equal to 1 by Ts. So the rate at which the signal is sampled expressed as a number of samples per second, that is the reciprocal of sampling interval, that is sampling interval is Ts. The reciprocal of Ts, 1 by Ts, is known as Fs, that is called as sampling rate. The sampling theorem or Nyquist criteria. So let me talk about the sampling theorem. That is, the theorem states that if the sampling is performed at the proper sampling rate, no information is lost about the original signal and it can be properly reconstructed later on if and only if the condition Nyquist criteria is satisfied. The Nyquist criteria or condition for sampling is given as Fs is always greater than or equal to 2Fm. So if a signal is sampled at a rate at least but not exactly equal to twice the maximum frequency component of the waveform, then the waveform can be exactly reconstructed from the samples without any distortion. That is given as the equation Fs is greater than 2Fm, where Fs is called as sampling frequency and Fm is called as maximum frequency of the modulating signal whenever the condition is satisfied, one and only if the signal can be reconstructed. It is otherwise called as Nyquist criteria or condition for sampling. The minimum sampling rate 2W, otherwise it is called as 2Fm. 2W samples per second for an analog signal bandwidth of W Hz is called as Nyquist rate. 1 by 2 Fs, Fs is greater than or equal to 2Fm. That is, the reciprocal of the Nyquist rate 1 by 2W is called as Nyquist interval, that is Ts is equal to 1 by 2W. The phenomena of presence of high frequency component in a spectrum is called as original analog signal, that is called as aliasing, that is the presentation of high frequency component overlapping the lower frequency component, that is called as aliasing. As the sampling theorem states, Fs is always greater than or equal to 2Fm. If it is sampled in this way, this aliasing can be avoided. So this type of sampling can be classified into 3 types. One is ideal type, which is not practically possible. It is otherwise called as impulse sampling. The next one is natural sampling and flat top sampling. In practically, we will discuss only natural and flat top sampling. So in my next video, I will discuss about natural and flat top samplings. So this is a quiz question based on the topic we discussed now, that is, the spectrum of sampled signal may be obtained without overlapping only if the condition satisfied is among these 4. As we discussed, Fs is always greater than or equal to 2Fm. If this condition is satisfied, then only the sampled signal may be obtained without overlapping. So this is the condition for sampling. Thank you.